Okay, so if you are asked to determine the location of the points of inflection at this point, it's just very easy to determine the distance, no? Because you can use ratio and proportion to solve for this distance. Okay, and this one also. So by ratio and proportion, you can determine the distances. On the other span, on member BC, this is a second degree curve. So how are you going to determine? So let's say this is your x, no? That is your x. So i-cut nimo ni siya dito, i-project nimo dito sa ibaw. Okay? And you will have this free body diagram. Okay? Okay, so project nimo na dito, no, kani nga point, and consider this as x. So project it there. So this will be your free body. Okay? As shown in our beam, you have a moment at C equal to 20.375, then your reaction, your load, and consider this distance x. So since you cut that point, which is the 0 moment, so you will have there shear at x and the moment at x. So sum up moment at this section equal to 0. So you have mx equal to 30.28125x, that is your reaction, times the moment arm x, minus 20.375 minus 15 times x times x over 2. And since at this section, ang imong moment is 0, so equate mo ng mx to 0. So you will have a quadratic equation. Okay, so using your calculator and considering your quadratic equation, you can solve for x. So the first value is 0.853 and the second value of x is 3.184. So as you can see in your elastic curve, okay, so kaniman duha ka points. So this one here is 0.853. So this will be 0.853, and kani paingon po diha is 3.184 meters. Okay, so that is your location of your points of inflection.